Welcome to Study Loop.
In this problem, we have a simply supported beam with a uniformly distributed load and a couple applied at the end A. Okay, so we'll find our reaction forces A and C, and then we'll use those to draw our shear and bending moments. All right, we'll look at point A, and we'll sum our moments, set them to 0. All right, we've got our 45 applied minus the resultant of the distributed load, 90 with an arm of 3, and then we've got our reaction at C with an arm of 7.5, and setting that equal to 0, we will get our reaction at C equal to 30 kilonewtons. And then we can sum our forces in the y direction, set them to 0. Right, we've got our A minus the resultant 90 plus a 30 equal to 0. And that gives us reaction at A equal to 60 kilonewtons. All right, and now we can draw our shear diagram. Okay, it's going to start with reaction at A. So we're going to start at 60, and it's going to decrease linearly with a slope of 15 until we reach length 6. All right, so we've got this going on, and then it will have a constant value. Right, so we can find our areas here. So this is, we're going to cross the axis at 4. So this point is 4 and 0. Right, that means our areas, we've got an area of 120 here, and our triangle here minus 30, and this rectangle is minus 45. All right, and now we can draw our moment. Right, okay, so starting with the applied, minus 45. Right, it's going to be a parabola. Okay, so it's going to be increasing up until we hit the 0 point on the V, and then it's going to, the parabola is going to start going down, and then it's going to be linear down to 0. Okay, so the peak, the maximum of our parabola is going to be at 4 and 75. All right, we started off at minus 45 and increased by 120. Okay, so the maximum bending moment, right, is going to be 75 here when we got to the point where our shear reached 0. Right? Okay, yep, so M max is 75 kilonewton meters, and that's going to be 4 meters from our end A.